Hello and welcome to ICND 2 Lab 3, RIP with split horizon, route poisoning, and poison reverse. All these features have to do with distance vector loop avoidance with RIP. For those of you using the Cisco Press exam certification guides, note that the material covered in this video is also explained in the ICND 2 books Chapter 8. Note that this video uses RIP version 1 in the examples. However, all the features demonstrated in this video work the same both in RIP version 1 and in RIP version 2. The objectives for this lab focus on what happens behind the scenes with RIP. In this lab, you'll learn better how to interpret the contents of the IP routing table, to determine which RIP update sources continue to send periodic updates to a router, and then to interpret RIP debug messages, in particular to see the effects of split horizon, route poisoning, poison reverse, and triggered updates. This relatively long lab uses three main scenario steps. In the first step, you'll take a look at the topology of a particular network and understand what routes should be seen in that network. Step 2 demonstrates how split horizon works by looking at the output of the debug IPRIP command. Step 3 again uses the debug IPRIP command, in this case showing how triggered updates, poisoned routes, and poison reverse routes work. As you see here, Router 2 and Router 3 are connected. There are three networks or subnets. The two LANs have a complete Class C network, and there's a subnet of Class C network 192.168.4.0 in between the two routers on the serial link. Additionally, as you see here, Router 3 has another LAN interface, which is another Class C network. Next, let's take a look at the routing tables on R2 and R3. R3 is connected to network 192.168.3.0 without any subnetting, so R3 has a connected route that you see there to reach that subnet. Once R3 advertises that route to Router 2 will also have a route to reach that network with next hop address 192.168.4.10, which is R3's serial link IP address. Similarly, R3 is connected to network 192.168.33.0, no subnetting again, so R3 has a connected route to reach that network. R2 will end up with a route to reach that network as well once it's learned using RIP, with next hop address 192.168.4.10. This same kind of thing happens over on R2. R2 is connected to network 192.168.2.0, so R2 has a connected route to reach that network. R2 advertises that route to Router 3, so Router 3 has a route to reach that network with next hop address 192.168.4.9, which is Router 2's serial IP address. Finally, both R2 and R3 are connected to subnet 192.168.4.8 with a /30 mask, as you see there. Next, let's look at the same information from the command line interface. Starting in R2, if you do the show IP route command, you'll notice indeed you see the same four routes you would expect to see. Focusing on network 192.168.3.0, note that it is indeed a RIP learned route, as shown with an R in the left-hand column. In brackets you see a couple numbers. The second one of those, the 1, is the metric for this route. If you look a little further, you'll see the via field, and that points to R3's IP address, the one that ends in 4.10, so that's the next hop router from R2's perspective. Moving right along, you see a counter that shows the number of seconds since R2 has heard about this route from R3. And then finally, at the end, you see serial 0/1/1, which is R2's outgoing interface with which to reach this network. Now take a look at the output of the show IP protocols command. If you look down toward the bottom, you see the routing information sources section. Notice the gateway listed there is 192.168.4.10, which is R3. And note toward the end the last update column. That shows the time that's elapsed since the last time R2 received an update from R3. If you repeat this command and look at the timer again, notice the timer changes. So if you want to know if you really are still receiving updates from that neighbor, just repeat the show IP protocols command and note that the last update timer for RIP should increase toward 30 seconds and then go back down to 0 because RIP updates should flow by default every 30 seconds. Next, at step 2, we'll take a look at the split horizon concept. R2 indeed has 4 routes in its routing table. But if you look closely, you'll notice that the last 3 routes in its routing table have an outgoing interface of serial 0/1/1. Now, split horizon rules say that on a particular interface, when you send an update, don't advertise about routes whose outgoing interface are that same interface. For instance, in this case, in this update that R2 is about to send out its serial 011 interface towards router 3, R2 should not advertise about the bottom 3 routes listed in its routing table. So as you see here, R2 sends an update only including that first route, the route to network 192.168.2.0, in its update send out serial 011 towards router 3. R3 also has 4 routes, but notice that the bottom 2 of the routes in its routing table reference an outgoing interface of serial 010. So when R3 sends its update out serial 010, split horizon rules dictate that he should not advertise about those bottom 2 routes. So notice there, the RIP update sent by R3 does not include those 2 routes, including only the first 2 routes shown in R3's routing table. To examine split horizon, we'll use R3. Here on R3, if we do the show IP interface command, serial 010, if you look about 12 lines down or so, notice the highlighted line says split horizon is enabled. So split horizon is on point-to-point serial links by default. To examine the contents of the RIP updates, we'll use the debug IP RIP command on router 3. Now this command will show messages each time a RIP update is sent or received, but since that might take up to 30 seconds, we'll do a bit of video editing to move ahead in time by about 30 seconds. Now it's a few seconds later, and we've edited the video. Notice I have lots of debug messages, and we've also already done the no debug all command highlighted there on the screen, which turned off the debug. Now let's take a closer look at the debug messages. Let's start with R3's received update. If you notice there, it says received version 1 update from 192.168.4.9, which is router 2's IP address. If you look at the line below it, it lists the one route in that routing update, namely 192.168.2.0, which is the one route you would expect to receive based on split horizon rules. Next, let's look at the sent update that R3 sends out its serial 0/1/0 interface. Notice the line here that says he's broadcast the update to the All255's IP address out serial 010. If you look at the 2 routes advertised, notice there's network 192.168.3.0 and network 192.168.33.0, the 2 routes that you saw a few minutes ago in the video that R3 should advertise, not advertising about the other 2 routes due to split horizon rules. Next, we'll move on to step 3 of this video. This step uses a sequence of 3 events that shows how triggered updates, route poisoning, and poison reverse works. First, at step A, you see that R3's FA0/0 interface fails. So R3 immediately reacts, sending a triggered update. Triggered updates by their nature being sent in reaction to some change, typically a failure in the network. Now notice this triggered update lists subnet 192.168.3.0, now with a metric of 16. A metric of 16 means infinity to RIP, so when RIP wants to advertise a route and say that it's failed, it simply advertises that network or subnet with metric 16. Anytime a routing protocol advertises a route with an infinite metric, that routing protocol is said to be poisoning the route, and that route is said to be a poisoned route. Finally, at step C, we'll see R2 react to that update. R2 immediately sends an update back toward router 3, so that would also be a triggered update. It'll include a route for 192.168.3.0 with metric 16, which is again a poison route. But because R2 just learned about this network from router 3 and turns around and advertises it back to router 3, then we call that a poison reverse route, advertising it back in the reverse direction from which it was learned. Before showing these features from the command line interface, next let me explain what the term in the title means, split horizon with poison reverse. Before this failure, under normal operations, R2 was only advertising one route, the route to network 192.168.2.0 that you see there. Once R3's FA00 interface failed, and R3 sent that triggered update to router 2, R2 reacted with this triggered update, only listing that poisoned or failed route that you see, 192.168.3.0 with metric 16. Ongoing after that, whenever R2 sends its periodic updates, he now includes 192.168.3.0 with metric 16 in those routing updates. In effect, R2 is suspending split horizon rules for a period of time for that one network that has failed. So the term split horizon with poison reverse is a short version of saying, we'll use split horizon, but we'll suspend those rules to send poison reverse routes as need be. From the command line interface, to see these triggered updates, we'll need to turn on that same RIP debug as well as shutting down R3's FA00 interface. However, the screen can get pretty cluttered if you do the debug command and then wait a while to go ahead and shut down the interface. So I'm going to do this sequence of commands relatively quickly. We'll start with the debug IP RIP command, then a config T, interface FA00, and the shutdown command. Now if we wait 5 or 6 seconds, we'll see a series of messages about sending flash updates and receiving them. And at that point, we can get out of configuration mode and do the no debug all command that you see there and turn off the debug. Now that sequence was obviously very fast. All I did was do the debug IP RIP command and shut down the interface, and then all these debug messages showed up. So let's take a closer look at those messages. If we look a little bit further down into the output, you'll see this message that says sending V1 flash update to the broadcast IP address via serial 0/1/0. So there's the flash update that router 3 is sending to router 2. And a couple lines below that you see network 192.168.30 metric 16. So there's the poisoned route. Notice there are no other routes listed there. This is a triggered update and it only has this recently failed route listed in it. Now if you look out to the left, you see a timestamp on those messages. Then I want you to look at the timestamp that we're highlighting just below it. Notice it's only a couple of seconds different there. The timestamp down below is the received version 1 update on serial 010 that happens next. That's the triggered or flash update sent from router 2 back to router 3. Notice it also advertises the same network 192.168.30, and it also lists that as a 16 hop or infinite metric route. So as you see there, as soon as we did the shutdown command, R3 sent the flash update poisoning the route, and within a couple of seconds router 2 got the update, responded with its own flash update, suspending split horizon rules and doing a poison reverse route that advertised that same 192.168.30 network. Also note that the regularly scheduled routing update, which happens about 5 seconds later in this case, lists both the poison reverse route to subnet 3 as well as the working route for subnet 2. This concludes IC&D2 Lab 3. In this lab, you've seen how to interpret the contents of the IP routing table in a Cisco router using the show IP route command. You've seen how to determine which RIP update sources are still sending routes based on the output of the show IP protocols command. And you've seen a lot about how to interpret RIP debug messages, particularly how to see the effects of split horizon, route poisoning, poison reverse, and triggered updates.